though, while everybody's getting settled in, just a quick introduction from myself. So my name's Tim Harney. I'm a partner solution architect with Amazon, AWS, working in the Boston office. So my role as a PSA is supporting all of our partner community throughout New England, primarily focused on consulting partners like Green Pages, who put together a lot of this event with us here today. And working in two facets. So number one, partner development, so helping our partners achieve our competencies. So when a partner registers with AWS, they could have specific competencies in AI ML, in DevOps, around industry verticals, retail, financial services, et cetera. So helping that partner facilitate the achievement of those competencies through training, certification, solutioning for their customers. And the second aspect is being tightly integrated with our customer and with the partner on the delivery of those projects. So working on large-scale migrations or net new app development and builds, and being a part of that whole process from ideation with the partner through delivery to the customer. So there's a whole team of us across North America. I just happen to be the one who's here in Boston and who's here to talk to you guys today. So from the earlier sessions, you guys got to hear from Danielle Greshok, who's on my extended partner team, and she gave a quick overview of some of the drivers, why people are driving to AI and ML and why it's important to their business. So today I just want to take it a little bit deeper, but not too deep in terms of technically hands-on, and talk a little bit about why machine learning makes sense now and how to get started with it. So up here you really see we have a couple things around the renaissance of machine learning. So when you think back to even the 1980s, 70s, 80s, 90s, the cost of supercomputing and the compute resources was really out of reach for a lot of organizations. So while machine learning and building algorithms and having data to throw at the problem was something that computer scientists, that PhDs, that mathematicians were thinking about, they really weren't able to use it for everyday problems that they may have wanted to. So with the cloud and with the democratization of access to compute, storage, fast internet bandwidth, we're really seeing a renaissance. When you think about the picture in the background as a processor, when you think about processor capacity and how far they've come in the past 25 plus years, it really opens the door to do some interesting things with your data. A little bit of background. I know Danielle talked a little bit about this during her presentation, but at Amazon, there's a pretty rich history of using artificial intelligence and making investments in machine learning. So everything from your personalized recommendations when you're shopping on Amazon.com, all the way over to the more recent things, such as the Alexa that you have at your house that you're having a natural language conversation with, to the Amazon Go store, which is the cashierless experience that started in Seattle and just launched a second store in Chicago recently. And the one in the middle, I kind of like that one, the Prime Air Amazon drones. So using everything from computer vision to capturing sensor data, because the drones are essentially IoT connected devices, and feeding that back into machine learning models to make them smarter. When we talk about the services, it's really the depth and breadth. So AWS as a whole, operating for 10 plus years, really has expertise in providing compute, storage, networking resources, as well as higher level platforms and services to our customers for building applications that make a difference in their business. When you think back to 2017, AWS launched over 1,400 new services and features that year alone. I don't have the numbers for this year. I'm sure we'll talk about them later on at reInvent, so stay tuned for that. And I'm sure it's going to be just as large, if not more, this year. So as you look, a lot of the storage, a lot of the DB analytics and democratization to that data allows you to facilitate these big data and AI and ML workloads on AWS. So you're getting your data into the platform, whether it's IoT data from sensors you've created, uploading your data to S3, or connecting your existing facility via Direct Connect to dump your data in. We have all these landing places for it, from DynamoDB, NoSQL solution, to our own Aurora engine on top of RDS, and S3, which a lot of our customers use as a data lake for running their machine learning and big data jobs against. And then, by the way, when you need to process that data, you're not alone there either. A lot of high-level services there, from EMR, our managed Hadoop service, all the way down to Athena, which allows you to write SQL queries and query data landed in S3 without actually loading it into a real database the way you might normally think of it. So want to talk about the stack, and we're going to go from the bottom up. So when we talked about frameworks and interfaces, the first thing that we want to think about on the bottom floor is the compute. So as I mentioned, compute is getting faster, more cores, higher throughput, higher thread count. So really what we have, the P3 chip, NVIDIA Tesla V100 GPUs. You can see over 5,100 tensor cores, 128 gigs of memory. This is the latest instance as of when I did this deck, 14 times faster than our previous iteration, the P2. And really, at the frameworks and interfaces level, this is for organizations that have established data science practices. Maybe they're coming from a supercomputing or a high-performance computing environment on premises, and they're bringing some of their own custom-built frameworks or leveraging frameworks at a lower level, the lowest base level abstraction layer, and bringing their own algorithms in. And that's why we also have the AWS Deep Learning AMI that comes with a lot of these frameworks pre-built. So in this space, it's for customers who are already doing some of this AI and machine learning workloads, who have been doing it on premises and want the flexibility to bring their tools to AWS. And we're giving very fast compute, very fast storage, giving a boost of speed so that you're taking advantage of that P3, or when the next generation is announced, you could take advantage of that without going through a lengthy CapEx cycle to refresh your 1,000, 2,000 node cluster that you're churning through your data with in your on-premises environment. The place where I want to spend the most time, though, is one level up the stack and in the top level. So between our platform services and application services. When you think about that bottom layer, the frameworks and interfaces, there's not a lot of practitioners who are available. Folks who have been hiring in the Boston area know it's very difficult to attract the type of talent, the machine learning, the data scientists. I know at Amazon, we're always hiring for those roles, so plug. I'd put my card downstairs if anybody's looking. Secondly, we're competing with universities here, especially in Massachusetts, between MIT, between Harvard, and a lot of the other large tech companies. So the competition for those data scientists is pretty fierce. What we're trying to do on the platform layer at AWS is provide a handful of pre-built platform services to really get the data and get your AI and ML workload kicked off and in the hands of your developers, so they could be putting it to use for your customers faster than building up a team and building up that competency. So in this level, the first thing I really want to talk about is SageMaker. So when you think about machine learning, it's too complicated for most developers to really jump in both feet, right? You have to, number one, build a bunch of compute nodes, cluster them all together. You need a team of operations folks to manage that cluster. I know iRobot was talking about that a little bit earlier as well, the overhead there. Then you haven't even got into collecting your training data, preparing your training data, understanding what algorithm makes the most sense for you to pull up and bring. Then you have to train and tune your model. All these are fairly intensive people processes that folks and organizations are trying to build their teams to manage these capabilities. With Amazon SageMaker, we're trying to make it easier to train and deploy your machine learning models. It removes the complexity that holds back developer success. You could get to production with machine learning much quicker. It allows you to set up an endpoint, an API endpoint, quickly deploys your machine learning models so that your other applications can consume them and make good use of them in your stack. So talking about the first stage here, when you think about the build stage, in SageMaker, there are pre-built notebooks for a lot of custom problems. So whether you're trying to pull in a k-means clustering algorithm or XGBoost algorithm that we heard about earlier today, or use some of the most common frameworks, Apache MXNet, obviously, but even Caffe2, PyTorch, and Torch are available. You're able to spin it up similar to how you would from an auto-scaling group and say, hey, well, I want these compute resources, I want these here, and I want to train this model. SageMaker does all that heavy lifting for you. So in the back end, it's worrying about the auto-scaling. It's going to help you select your algorithm because we have the 10 pre-built ones. And it's going to allow you to directly import data from S3, from any of the database sources that I mentioned on the previous slide, or even do some ETL jobs before it gets there using Glue or EMR to land your data, your training data into SageMaker. Next, you want to start training it. And here's where you want to think about the supervised and unsupervised learning. So hyperparameter tuning or hyperparameter optimization is a form of supervised learning, and it's basically doing regression problems against your data. You're saying what you're thinking you want to get out of it. You don't need to be a mathematician or statistician to say what we want to look to get out of these discrete data points is something around here. You're tuning based on the variables that you think are going to be most impactful. The other nice thing about being able to do one-click training and training your data model with something like SageMaker is that you could go through multiple iterations. So if your original assumptions were wrong, rather than having all this hardware constantly churning against it, you could delete it, start back over. All your data is resident, your data is living in S3. You could bring your data into SageMaker and you could train against a new model that your team is thinking about testing, and you could try all of your, all the pieces of data that you really want to get your insights out of. And then lastly, you'll see the theme, one-click deploy. So a lot of times, the other really difficult piece for an organization is after you've trained, after you've built your models, how does our application consume it? In the case of doing a product recommendation engine or something like that, how do we allow our web front end to consume that model? For maximum versatility, this creates an API endpoint. So your application could make an API call. It could say, hey, give me this, and is going to be able to pull that data straight from your model. And by the way, as customers, your customers are leveraging that solution, whether they're internal customers or external customers, clicking on a link or clicking on some content, you're going to be able to take those logs and feed it back in and continue to train that model as you go. So you can see this end-to-end loop where it's fully managed. The API endpoint is going to auto-scale up to meet the demand of your application, internal or public-facing, and from there, be able to then continuously train your model to refine your delivery. Oh, sorry, I went backwards. Interesting thing is, like, could we do more to put machine learning in the hands of developers? Literally. So those of you who attended, and show of hands, did anybody attend reInvent last year or watch any of the live streams? A handful. So one of the big things was the AWS Deep Lens. And Deep Lens is a high-def camera. It has onboard compute. So it's running Greengrass in it, which is our IoT platform, and that allows you to run machine learning at the edge. So the purpose of this wasn't to be a production grade, let me set this up and deploy thousands of these across our organization. It was to get machine learning in the hands of developers in a way that they could wrap their heads around it and start using it day one. So being able to leverage the video camera, the audio, the microphone, to build and train a model at the edge, on the device, kick video streams up to recognition, which we'll talk about later, and get insights from that video stream is a really powerful tool. You see there from unboxing to first inference is less than 10 minutes. There are a lot of great online tutorials. If you guys haven't had a chance to experience a Deep Lens, let me know. We could talk about how we could do something with your organization in the future, or I could point you to a link where you could buy one. But it's a really cool device, and if you want to get your feet wet and jump in with machine learning, it's a good place to start. All right, that brings us to the top layer of the stack. This is for developers and companies who want to add more intelligence and is purely API driven. So in SageMaker, where you're worried about doing a lot of the training data, this is going to be the highest abstraction level where there are some existing services that Amazon has built that you could consume natively. Those ones are listed here. So we have recognition, which is for video and photo recognition, transcribe, which takes speech and puts it to text, translate, which could translate a variety of languages, Pauli, comprehend, and Lex, which are all around natural language processing and natural language understanding. And we talked a little bit about Lex earlier in terms of chatbots. So recognition is deep learning based image and video analysis. So the types of workloads that you could leverage for recognition are object and scene detection, so you could understand, is this picture or is this video taking place in the desert or in the city? Is the person riding a bicycle or are they walking? You could also leverage facial recognition and facial analysis to get some inferences there, even with live stream video, which is really powerful. Finally, the cool one, had to include Big Papi, if you didn't notice the Red Sox hat, but celebrity recognition is also a feature of there, and we've worked with customers who have taken historical videos and content that they produced, and been able to go back, feed it through recognition, and annotate it, so when customers are searching for content, they could understand what celebrities were being interviewed or are present in that content. So some really powerful use cases here. Some other interesting use cases when you think about person tracking or object and scene recognition and activity are around traffic patterning, so understanding where people are walking in a given facility, or understanding how many cars are driving down a street at a certain time as cities are going to develop, better traffic grids and light detection. So some use cases there, and there's a lot more on the web that I could share after the prez. Amazon Transcribe. So this is really interesting. There's a lot of data that's been locked up in audio and video. I forget the exact statistics about how much content is uploaded to YouTube and now how much content is streamed on Twitch daily, but there's a lot. So being able to take that audio, that video feed, and put that data into text so that you could then feed that into your machine learning algorithm, or take it from something like Transcribe and feed it into another service, whether it's Translate or Comprehend, to take it from one language to another to provide better subtitles, better closed captioning. Take it from translation then to a Comprehend, which could give you sentiment analysis, so understanding the speaker's intent and their emotions around the topic that they're speaking on is a pretty powerful thing that gives you metadata that you could then go train more of your machine learning models with. Some big features here are being able to recognize multiple speakers, support for telephony and audio from telephony, and that's a really powerful API-driven feature that a lot of our customers leverage when they think about Amazon Connect and the call center technology. So being able to do speech to text and land those text transcripts from their various call centers, help desks, et cetera, in their S3 bucket, and then process through some other machine learning workloads to understand, hey, was the customer happy at the end of this transaction? Because the customer might not have stayed on the line and done the survey when they closed that conversation. Amazon Translate, so we talked a little bit about that. Real-time translation, batch analysis, automatic language recognition. I don't have the updated list of what languages are available because I believe there was just an announcement about a new language last week, so I didn't want to risk it, but I could provide the link. It's a growing list of languages that are available as part of the Translate. So Pauli is the next one, and if anybody has an Echo device at home, anybody? Hands? A couple people. You're familiar with that because that's taking text into lifelike speech. So the voice will sound really familiar. There's also a big selection of different voices that you could choose. This has different voices, different languages. You're able to have fine-grained control over what the utterances are that Pauli could speak and what text you could feed it. It's a pretty powerful solution as people are building more lifelike chat interactions, whether it's through Connect in the contact center or through something like a chatbot like Lex. Amazon Comprehend, we talked a little bit about that earlier, but Comprehend can understand documents, social networking, posts, any other data, really, text data. It uses natural language processing to give you highly accurate information about what it contains. And I think the four main categories here are entities, key phrases, language, and sentiment. So that's going to allow you to understand who is speaking, identify two different speakers. You're going to be able to understand what their intents were, and you're going to get all this in a format that you could use, that you could dump back into S3, and again, feed further machine learning models like a SageMaker so that you could bring your own algorithms. Some example use cases there, so going back to the contact center, the call center is taking a swath of your call center transcripts, being able to leverage them and comprehend and understand, hey, by applying this algorithm, are we seeing at this time of day more happy customers, more upset customers, or after a certain product announcement or a feature release for your organization, what type of calls are we getting? So being able to get those inferences from the utterances that you're recording as part of your call center, being able to take those inferences, feed a model, and change your business practices coming out of it to be better successful for your customer is the real power of leveraging all of these API services together. This is the other interesting thing that Comprehend can do. So it's to discover interactions and relationships between text. So you could think about a library of news articles, and it's topic modeling. So understanding how you could take all these different topics from all these discrete data sources, and you'll see on the left kind of a list and a library of news articles, run it through Comprehend, and then separate those articles out so they're much more topical. And then again, you could make your own inferences from that data. You could feed it into an advanced machine learning model and understand, hey, today of all the news articles, 90% we're talking about the Red Sox going to the World Series. What's the sentiment of those articles? Are they positive? Are they negative? So you could see how you could chain these services together and get really interesting insights based on your needs. Last, Amazon Lex. So Lex is the chatbot platform that you heard talked about a little bit earlier today. It's integrated in the console. It triggers a whole handful of Lambda functions. You could do multi-step conversations. It's one-click deployment, and it's a conversational interface for all of your applications. So since it's API-driven, since it could trigger Lambdas, since it could communicate with other AWS services, you could have very immersive and very interactive experiences where a customer is calling using the Connect product or chatting on the web and typing text, and it's going to take that text and say, hey, tell me my account balance. And it could say, well, which account? And list off your accounts as an example and do things like that for your customers. Or say, I want to reorder my prescription. Which prescription do you want to reorder? Or do you want to ship to the same pharmacy? So there's a lot of different interactions when it's using its natural language understanding to parse out what you're uttering to it and giving you access to that as text, which you could then feed to the rest of your applications and take it from your applications back to Lex to give the customer an answer that makes sense in the process of a conversation. So just to wrap it up here so that we have some time for questions at the end, AWS has the broadest platform, very easy to use, and we also have the most customers. So when you think about, we talked about the complementary services very early on, how you get your data in, whether you're landing in S3 or it's in one of our database services, DynamoDB, all the way up through RDS and even Redshift, our data warehouse. But also the machine learning platform that we just went through. Being able to bring your own frameworks, your own interfaces, if you're an in-depth practitioner, all the way up to the application layer where you're able as a developer to include these applications and include these APIs in your application to better serve your customer. The next step really is the Amazon ML Solutions Lab. So this is an offering from Amazon where we have practitioners from our ProServe organization who could come out and they could do machine learning skills development and enablement for your organization as you're thinking about embarking on this journey. It's a couple-day session. They go through brainstorming, some custom modeling and training, and you get to work side by side with some hands-on practitioners from Amazon to help enable you on your AI and ML journey. And one thing that we always like to say is there's no compression algorithm for experience. So these are the folks, both from Amazon and from our partners, who have built and developed these solutions using all of these platforms from the frameworks all the way up through the application layer and have helped customers solve really hard problems leveraging the technology and leveraging the solutions. So with that, that's what I had. So I want to open it up for any questions that folks may have. Yep. Yes. So Lex, the way to think about Lex is that it's something that Amazon is training on your behalf. So in aggregate over all of the Lex platform. So where if you kind of went down 2 layers to the frameworks and interface and chose your own natural language understanding or ASR, you would have your training data and you could continuously retrain it yourself. There's the option, you could submit data in and you could retrain, but Lex has like a finite skill set and capabilities, but we could talk like more in depth about your use case and figure out what makes sense for training it.
How does the SageMaker, suppose I want to train the data, something like that, to SageMaker, so we know like for the testing or training, you need a lot of data to analyze sort of thing, right? So how does the data would be stored in the SageMaker?
No, so the data would be stored in like S3 or in a database, right? SageMaker could communicate with those data sources. So what's typical for our customers who are like launching a data lake, they'll have their data lake platform be on S3. They have a lot of raw data, whether it's sensor data, log data, whatever data is important to them. They'll have some type of ETL or enrichment process where they say, hey, we want to combine this with some data we have in a database or in another S3 location. And then they land that somewhere. And then that could be the seed data that you'll have SageMaker call to for the training.
So is there a way that the SageMaker can compare my previous model with the current model?
Yeah, there's A/B testing with SageMaker. Okay. So you could train a new model with.
A couple of
yep.
models training down, then I want to go with which model can go for the
Yep.
production.
Yeah, 100%. Yeah, that's a common use case.
So on the ML Solution Lab training, so is there additional cost when already on existing AWS account or?
With the Solution Lab?
Yeah.
So Solution Lab is more of an engagement level of people, not necessarily an additional a charge on your account. Mm-hmm. We have like joint offerings with our partners, but also we have the ML Solution Lab from within AWS, who depending on the use case, they could work with your account team and figure out if it's a paid multi-day engagement or a half day of like some type of enablement for your team. Mm-hmm. So there's different options to get enabled.
There's one more thing on that. So we have a lot of algorithms to be already built in the SageMaker.
Sorry, a lot of what?
The algorithms.
Okay.
Whatever we have, suppose we want to put out one algorithm. What sort
yep.
of scripts could be supported? Like usually it's R or Python or some other.
Yep. So you could bring out like we could talk in detail afterward, but basically you could sideload your own algorithm or your own framework even in a container. So if it's not one of the frameworks that we have, you could sideload that into SageMaker, and I could talk to you about that. Sorry.
So with your solution labs, do you have SMEs or domain experts that you could
Yep.
do a particular business?
Exactly.
Okay, great.
Yep.
So in the SageMaker, there is a reference to notebook. So that is launched the Python notebook?
Yeah, so the Jupyter notebook. So you have a yeah.
So does that spin off the EC2 instance for you, or is there any other server that maintains the Jupyter notebook?
So with the Jupyter notebook, it'll have its own instance just for the Jupyter notebook when you launch one. You could schedule it, with scheduled lambdas or with CloudWatch to shut down if you're not using it. So there's different ways. Yeah, yeah, exactly. Yep.
Does SageMaker connect that into my regular set of systems? Like if I want to use that for development, train a model, and some stuff on it, and then I want to take that and pull it back into my own space within AWS, does that workflow even make sense?
When you mean pull it back, yeah, like what do you mean by pull it back in?
We're training a model, we've got data.
Sure.
We've got the outputs from that.
Yep.
Is there a quick and easy way to pull that out, or I just have to write some code to then take that and then run that in my space? Like going forward, would I have to continue to run stuff in the SageMaker space? Or run stuff with that in my own EC2 instance?
It depends on the use case, right? So if the nice thing about SageMaker with the one-click deployment is it's handling that API endpoint and the auto scaling of that endpoint for your applications to talk to. So if you for whatever reason decided, hey, it's great the SageMaker trained it, but now I want to take this model and run it on my own EC2 instances, you could potentially, you're using an algorithm, you're using a framework, either one of the pre-built ones, plus the training data, which you have resident in S3, or you siloed your own algorithm and framework. So if you wanted to do that in EC2, you definitely could, but then you have to think about the scaling of the API endpoint and all the other pieces that go along with it. Yeah. Yep. Cool.
What's the scale of the training data for SageMaker?
When you say scale.
Gigabytes?
It varies, right? As much data as you could throw at it that makes sense for your model. So I don't have any hard numbers about what's like the minimum customer data or what's the maximum a customer's done, but there's a lot of data in S3. We talked about it briefly on one of the previous slides, but the way to get data in, there's Direct Connect, there's Snowball and Snowball at Edge, which are 80 to 100 terabyte boxes that customers are shipping in. And then 2 years ago, there was also Snowmobile, which is petabyte scale migration into AWS. So people are onboarding petabytes and petabytes of data into S3, into AWS, and they're using that data to train models. Anything else, or?
One question
Yep.
about the snowmobile. So, can you just give an example? How many use cases or how many customers roughly?
I don't have any references to how many customers are using the snowmobiles today, but they're definitely being used.
How long would it take to load a petabyte of data?
So that's an interesting thing, right? So like if the snowmobile is like a tractor trailer that pulls up to your data center with like 100 gig plus cross connects, so you're going pretty much as fast as your disk will spin in the data center to get it into the snowmobile, and then however fast they could drive to the AWS facility to upload it, right? So it's kind of the classic sneaker net problem. You could have a 10 gig direct connect, but if I could put it on this snowball and ship it, is that going to be faster? So it's really whatever makes sense for the customer and the amount of data they're trying to move. Yep.
I have a very fundamental question.
Sure.
So does the AI, I guess would be in my case, work on the metadata itself, the metadata of your data set, or does it actually go into, let's say I have thousands upon thousands of just text files? Does it actually dive into each of the data files? Or
Depends on what you want it to do.
okay, so it has the
All,
quality.
yeah, yeah.
Okay.
Yep, no problem.
So there is in one of the slides show like it's build, train, and deploy. So is test not part of like how do you do it from dev to prod?
From dev to prod. So I think with the dev to prod, it's almost like this gentleman's earlier question of like how do you train different models, or how. So you might have an idea that the inference that you want to get is X, and we want to try this algorithm for whatever reason, and you're going to run that through the training. You're going to deploy as an API endpoint, and you're going to consume it and look at that data and say, is this what we thought it was, or is this something different? And then you might go back and train a new model and do an A/B test and say, does this one give us better results? So it's a little bit different paradigm than the dev prod type paradigm, but you're deving your algorithm, your framework that you want to use against your data set. Say again?
It's trial and error.
Yeah, exactly. I think that's the common pattern I've seen customers use.
So on your website, you have built out architecture use cases for reference architecture.
Yeah, so I think there's a couple resources. I'll make sure we send them out. Like on the main website, if you search for SageMaker, there's some good customer use cases there that you could go read through. If you check out the AWS like AI/ML blog, there's constant stream of blog posts as well as links to some open source projects that people have posted, so that if you wanted to get a hands-on or get some experience within your environment, you could go to their GitHub, pull it down, and you could test it out. A lot of content up there. Cool. All right, well, if nothing else, I'm around, so feel free to come up and ask me a question. I'm hanging out for the rest of the day here before the next session, and I think there's drinks and stuff outside. Thanks, everybody.